Hello everyone, so welcome to my YouTube channel. So guys, we are going to start with the chapter number 4 for the CET course for the chemistry, and the chapter number 4 is chemical bonding and molecular structure. So where you will get this, go to my channel, go to the playlist. In playlist you will get a Kcet course. So in Kcet course you are going to get this. Okay, तो चलो तो भैया चलो, we'll start with this. Okay, yeah. So this is a synopsis of chemical bonding and molecular structure. So first of all is what? Octet rule. What is octet rule? We know 8 electrons rule is a octet rule. So where the 8 electrons will be present? In the valence shell. Guys, we know valence shell or outermost shell all are same. Okay. So octet rule, it should be in valence shell. Valence shell means in valence shell we want 8 electrons should be present. So it's called octet rule. Means octet means 8 electrons rule. So here atoms can combine. How atoms can combine? By transfer of valence electron. Obviously we know the valence electron or outermost electron, they will transfer. So atoms can combine by transfer of valence electron from one atom to another, or they can be doing gaining or losing. Okay, so transfer, what do you mean by that? Gaining or losing. So now see what will happen when you will transfer. We will see either gaining is happening or losing is happening. So whenever there is a gain of what? Electron. Whenever there is a gain of electron, it's a negative charge, and what will happen? The size will increase, so it's called as anion. Wherever there is a loss of electron, loss means it is giving, the loss of electron, the charge is positive charge, size will decrease, and it is cation. So it for octet rule, guys, it attains stability. Stability means complete valence shell. So that's why we want 8 electrons should be filled in valence shell. So that's why it's called a complete valence shell. And you know, whenever there is a complete valence shell, it's attained stability. Attained stability means there is a less reaction because it attains stability like a noble gas. Okay. Now next, limitations of octet rule. The incomplete octet of central atom. So whatever the central atom, it have an incomplete octet. In few atoms we have seen that the central atom is having incomplete octet. In some cases expanded octet of central atom. In some cases we have seen that we can expand the octet. We can expand the octet of central atom. Then octet rule, it does not explain the shape of molecule, fails to explain the relative stability of molecules. Now we'll come for the ionic bond. We know what is ionic bond. An ionic bond is formed by transfer of electron. Guys, understand very important thing, what is happening and between whom, that is important. So ionic bond means an ionic bond is formed by transfer of electron. Here what is happening? Transfer of electron. You can see here in covalent bond, what is happening in covalent bond? It involves sharing of electron, not transfer. Guys, transfer means from one atom it will go to another atom. Either it will lose or other will gain. So that is a transfer. Means one electron from here it will jump to other atom. That is called transfer. Sharing means what will happen? Sharing is like this. Okay. So transfer and sharing both are different. So ionic bond, what will happen in ionic bond? Ionic bond is formed by transfer of electron. So in ionic bonding, what is happening? Transfer of electron is happening. Between whom? From a metal to non-metal. So there is a transfer of electron from metal to non-metal. Means what do you mean by this? This means that metal is losing electron because there is a transfer of electron from metal. From metal it will transfer to non-metal. So guys, we know metal have a tendency to lose electron, so that's a metal are losing electron. Whenever it will lose the electron, it will become plus charge, so metal will become cation. And non-metal have a tendency to gain electron, so from metal the electron is going to non-metal, so non-metal is gaining. When it is gaining, it has negative charge, so non-metal is become anion. Okay, so what is happening in ionic bond? Ionic bond is formed by transfer of electron from metal to a non-metal in order to obtain a full valence shell for both atoms. Electropositive element, guys, from the name we will understand. Electropositive element means electropositive. So when it will become positive, when it will lose electron, correct? So see, electron lose. Who will lose the electron? Metal. So whenever there is electron lose, so it's become electropositive because electron is losing. So whenever electron is losing, it's a positive. So electropositive element when electron lose. And same when electron is gain. Electron is gain means what is happening? Gaining means negative. So that element will become electronegative element. The element which gain electron is become electron negative, because gaining electron means negative, so it will become electron negative. So who is gaining electron? Non-metal. Just now I explained. Okay. Key factors for the formation of ionic bond. Ease of formation of positive or negative ions from the respective neutral atoms, because here the transfer of electron will happen, so it is easy to form the positive or negative ion. So who will become the positive ion? Which is losing the electron. And who will become the negative ion? Which is gaining the electron. That's it. Arrangement of positive or negative ions in the ionic solid. Then ionization energy. Guys, see what will happen in ionization energy. Wait a moment. Bolo bhaiya. What will happen in ionization energy? Guys, we know ionization energy. What is the definition of ionization energy? Let's see here. We have a definition of ionization energy. किधर गया भाई? अरे क्यों भैया किधर चले गए? Wait. See, I know you know the definition of ionization energy. Okay, in the previous chapter we had studied about the definition of ionization energy, right? The energy required to break the bond or remove the energy required to remove the electron from its valence shell, right? Yes, sir. No. Okay, fine. Guys, see what will happen in ionization energy. Ionization energy means energy required, right? Energy required to remove the electron from its valence shell, correct? So energy required. So energy, whenever we are taking the energy, what is happening? We are taking the energy. So taking the energy means heat will increase, correct? So ionization energy means energy required to remove the electron from its valence shell, correct? So whenever we are taking the energy, so what is happening? Taking the energy means we are absorbing the energy. So absorbing the energy means ionization energy is always endothermic. Endothermic means will absorb the energy. Okay. Sorry. So it will be a positive. Okay. So what is ionization energy? We know ionization energy means energy required. We are requiring the energy. So requiring the energy means we are absorbing the energy to remove the electron. So whenever there is absorption of energy, it is endothermic. So ionization energy is always endothermic and it is positive because it's absorbing. Okay. Now electron gain enthalpy. Electron gain enthalpy, we know the definition of electron gain enthalpy is studied in the chapter number 3. So electron gain enthalpy, what will happen here? Here energy released. Electron gain enthalpy, what is happening? Energy is released, correct? So whenever energy is released, it is a exothermic and it is a release, so it's a negative. Okay, so this too is important. Now next is lattice energy. Lattice energy means energy required to completely separate 1 mole of a solid ionic compound into gaseous constituent. So I see lattice energy. When we are using the lattice energy, energy required to completely separate 1 mole of solid ionic compound. So we have a 1 mole of solid compound which is in the form of ions. So we have to separate into gaseous constituent. Okay, so we have a solid compound in the form of ion, okay, into gaseous constituent. Okay, now covalent bond, it involves sharing of electron, not transfer. Okay, sharing of electron pairs between two atoms. So sharing means what, guys? Sharing means the electron will be with them only. Okay, it's not that X will lose the electron, it will going to Y, or Y lose the electron, it will going to X. No, they are sharing and they are making a bond. So that's why it involves sharing of electron, not transfer. So sharing of electron pairs between atoms. So which? Between non-metals. So both are non-metal atoms. Both are non-metal atoms. So this we know: single bond, double bond, triple bond. Single bond means sharing of 2 electrons. Double bond means sharing of 4 electrons. Triple bond means sharing of 6 electrons. Okay. Now we'll come for the bond parameters. Bond parameters, first is bond length. Guys, we know bond length. This is the bond length. Okay, the length of the bond. So equilibrium distance between the nuclei. So equilibrium distance between the nuclei of 2 bonded atoms. So this is the 2 bonded atoms. So this is the nuclei. So equilibrium distance means this radius. This from here radius, from here radius. So this radius plus radius, this is total of bond length. Okay, so equilibrium distance between the nuclei of 2 bonded atoms in a molecule is called bond length. Bond length is measured by X-ray diffraction, spectroscopy, electron diffraction. Next is bond angle. We know this is the bond angle. So bond angle means angle between the orbitals containing bonding electrons. So this is the bonding electrons. This is the bonding electrons. So angle between the orbitals containing bonding electrons pair around the central atom in a molecule or complex ion. So it expressed in degree. Every time bond angle is expressed in degree and determined by spectroscopy. So these are the important point you have to remember. Bond enthalpy, guys, enthalpy means nothing but energy required, right? So bond enthalpy means energy required to break 1 mole of bond between 2 atoms in gaseous state. Why we are using gaseous state? Because it will become very easy to break the bond in gaseous state. Okay, so bond enthalpy means energy required to break 1 mole of bond between 2 atoms in gaseous state. Next is bond order. See, all we know about the bond order. Bond order is nothing but the number of bond. Okay, number of bond between 2 atoms. That is called a bond order. Like here you can see what is the number of bond between hydrogen and hydrogen. We have a just 1 bond. 1 bond means bond order is 1. So how many bond between nitrogen atoms? We have 1, 2, 3 bond. 3 bond means bond order is 3. If it is double bond means bond order is 2. So that's it. Bond order is nothing but a number of bonds. So with the help of electron dot structure, everyone knows, guys, electron dot structure, right? Electron dot structure will make with the help of valence electron. Okay. So with the help of electron dot structure, we can find the types of bond between 2 atoms, right? You know, if you will know that electron dot structure, how to draw the electron dot structure. So when you will draw the electron dot structure between 2 atoms, then you will get to know whether it is like, you know, bonded with 1 bond, double bond or triple bond. Isoelectronic molecules. Iso means, guys, same. Electronic means electron. So same electron. The molecules which is having same electrons. The same electron molecules and ions have identical bond orders. Okay. So what we understand here, isoelectronic molecules and ions, they have identical bond order. Okay. If I will increase the bond order, bond enthalpy increase, bond length decrease. Guys, bond order means suppose single bond. Single bond, the bond enthalpy means energy required to break the bond. So if it is single bond, easy to break the bond. Now if I will increase the bond order from single bond to double bond, means bond order is 2. Then we have a 2 bond. Then energy required to break that 2 bond is difficult. So bond enthalpy is what? See, this is a single bond. The bond order is 1. So easy to break. Right, the bond enthalpy is less. See, bond order, this is the what? Single bond. Single bond, the bond order is 1. So enthalpy means, bond enthalpy means energy required to break the bond. It's less. Now I will do this. This is what? This is a double bond. Double bond means bond order 2. Now this double bond is difficult to break. Means we have to require the energy more. Now if I will make a triple bond. Triple bond means bond order 3. So bond enthalpy means more energy required to break the bond. So as the bond is increasing, single bond, double bond, triple bond, the energy required to break the bond is increasing. So that's why bond order is increasing, bond enthalpy is increasing, and bond length is decreasing. For single bond we have a higher bond length, then double bond, then last triple bond. Triple bond means bond length is decreasing. Okay, because see, if long length easy to break, small length difficult to break, correct? So that is the thing. So if I will give you this, you will break it easily, but half of this you have to require more energy to break. So that's why bond order is increasing, single bond, double bond, triple bond, bond length is decreasing. Why the bond length is decreasing? Because as the bond order is increasing, we have to require more energy to break. More energy to break means bond length is short. So that's why we require the more energy to break. Okay. Now dipole moment. Dipole moment means no bond or a compound is either completely covalent or ionic. We can't say that any bond or a compound that is completely covalent or completely ionic. It's not possible. So dipole moment is a measure of separation of positive and negative charge in a molecule. So suppose we have a positive charge here, negative charge here. So what we will do? Dipole moment is a measure of separation. So we know dipole moment formula is what? Charge into distance. So this charge and then the distance between them. Okay. It indicates dipole moment. This is important point, guys. What dipole moment indicates? Dipole moment indicates the polarity of a bond or molecules. Polarity, whether it is polar or non-polar. So dipole moment indicates that whether it is polar, so how much polar, or it is non-polar. SI unit is debye, D-E-B-Y, debye, represented with capital D. So what is polarity? Like polarity in a bond refers to development of partial positive and negative charge in a bond due to difference in electronegativity between bonded atoms. So guys, see what will happen. Polarity is nothing but it indicates the partial positive and negative charge in the bond. Okay, there is a partial positive and negative charge in the bond. Okay. So what is polarity? Polarity in a bond refers to the development. Whenever there is a polarity, we'll say, oh, the bond is polar. Means what? Polar means, we see, understand one thing. Polarity, polar and non-polar. Okay. So whenever we will say polar bond means, see, every, like if we'll take the atoms, so everywhere we have a positive charge and negative charge. If the number of positive charge and negative charge is equal, then it is a non-polar. Polarity is not there. But if we will see either positive charge is greater than negative charge or either negative charge is greater than positive charge, then in that case we will say polarity is there. Okay, because we don't have a equal distribution of positive and negative charge. If we have a equal distribution of positive and negative charge, it is a non-polar. Polarity is not there because it is a equal distribution of positive and negative charge. But if there is not a equal distribution of positive and negative charge, means either positive charge is more or either negative charge is more, in that case we will say it is a polar bond, means polarity is there, the difference is there in the positive charge and negative charge. That's what they said. Polarity in bond refers to the development of either partial positive and negative charge in bond due to difference in electronegativity between bonded atoms. So if we are increasing the polarity, electronegativity difference will increase. Electronegativity difference means electron negativity difference is increasing. Okay, either it have a more negative charge or more positive charge. So if there is a difference in electronegativity, polarity will increase. So polar covalent bond is what? In which the shared pair of electron is unequal distributed. So as I have told you, right? Unequal distribution of shared pair of electron means polar. Okay, unequal distribution means what guys? Number of positive charge is not equal to number of negative charge. समझ में आया? बहुत बढ़िया. अरे वो प्यारे, देखो भैया ये चैप्टर, दिस चैप्टर is bit gijbij. Only the electron is sharing, electron is taking. So you have to be, more imagination. You have to be like more in a imagination power. Like you have to imagine the electron is moving here, there. Okay. So unequal distribution means positive charge and negative charge are not equal. So then it will become polar. In non-polar covalent bond means in which shared pair of electron is equally distributed. Guys, if anyone will say that we don't have charge, don't say that in non-polar covalent bond no charge. No, charge is there, but net charge is not there. Okay, charge is there, but net charge is not there. Okay, charge is there, but net charge is not there. Okay, fine. So what does this mean guys? Charge is there. Charge is there means number of positive charge and number of negative charge are equally distributed. So charge is there but net charge is zero. So polarity and non-polar depends upon net charge. Okay, in polar covalent bond net charge is not zero. Okay, so see here, in polar bond we know that electronegativity is not equals to zero because we don't have a net charge as zero. But in non-polar bond electronegativity is zero because we know that, yes, correct, we know that net charge is zero. Okay, what is shape? Shape is symmetrical. Shape is symmetrical means guys shape is similar. If shape is similar then dipole values cancel each other and it become non-polar molecule. So dipole cancel each other means value will be 0. So 0 means non-polar molecule. If shape is asymmetrical, asymmetrical means shape is not same, then dipole moment does not cancel each other. We will get some values. So it is a polar molecule. Okay, it will show the polarity. So this is how we represent the dipole moment representation. So this arrow indicates that means the electron is moving towards more electronegative element. Guys, we know the electronegative element, it attracts the electron. Right, suppose it is a hydrogen fluoride. So what is happening? We know that fluorine is more electronegative. So what will happen? Fluorine will attract the electron towards itself. So this arrow indicates that electron is moving towards more electronegative element. Okay. Now next we will start with VSEPR theory. Guys, we know that full form of VSEPR, valence shell electron pair repulsion. So what is happening is valence shell means, see, whenever we will talk about electrons, we will talk about the electrons in valence shell. We will not talk about the electrons in inner shell. The reason behind is in valence shell only, either we will remove the electron or we will add the electron. We will not do anything in the inside shell. Okay, so in valence shell electron pair repulsion. Okay, so VSEPR means valence shell. In valence shell electron pair repulsion will happen. Okay, so Powell and Sidgwick proposed valence shell electron pair repulsion theory in 1940. Before independence only they had given this. See, independent 1940 and all, people were fighting for the independence in our India. Powell and Sidwick, they are busy in VSCPR theory. See, shape of molecule depends upon the number of valence shell electron pair around the central atom. So what will happen if they will ask shape of molecule depends upon number of valence shell electron pair. Guys, very important. Number of valence shell electron, not number of valence shell electron pair. Okay, around the central atom. See, pairs of electron in the valence shell repel one another since their electron clouds are negatively charged. Suppose this. Wait. What they said, pairs of electron in the valence shell. Suppose we have a pairs of electron in the valence shell very near to each other. Guys, we know electron consists of which charge? Bolo re bhaiya, electron consists of negative charge. So guys, if I will bring the negative charge closer, so what will happen? They will repel each other, right? That's what they said, pairs of electron in the valence shell repel one another. Why? Since the electron clouds are negatively charged. These pairs of electrons tend to occupy such position in space that minimize repulsion. Means what will happen? We will not place them together. So what will happen if this is a valence shell? So this pair of electron, tends to occupy such position in space. They will occupy such position in space that minimize repulsion. So when it will minimize repulsion, guys, see, this is a valence shell. If I will bring the electron together, the repulsion is very high because both electron is negative charges. Like charges repel each other. So what will happen? They will occupy that position that minimize repulsion. So when it will minimize repulsion, that maximize distance. If I will increase the distance between these two electrons, in place of here, I will place the electron here. So what I did, I increase the distance. If I will increase the distance, what will happen? The both electron is far. Now the repulsion is less. Electron pairs are at maximum distance from one another. So we should have to keep maximum distance. So that's why the repulsion should be minimum. Now multiple bond treated as single electron pair. Okay. 2 or 3 electron pair treated as single super pair. Remember the thing, multiple bond treated as single electron pair, 2 or 3 electron pair treated as single super pair. Okay, so multiple bond treated as single electron pair and 2 or 3 electron pairs treated as single super pair. Okay, now see here, lone pair repulsion. Lone pair repulsion means we have a this side. Suppose this side we have a electron lone pair and this side also we have electron lone pair. So what will happen? Lone pair repulsion is more as compared to lone pair bond pair repulsion, which is greater than bond pair repulsion. See, bond pair already it is bonded. So whenever it is bonded, it attains the stability. If it is attaining the stability, repulsion is very less. So if it is lone pair, then repulsion is very high because it is not bonded and two electrons are close to each other, they will repel each other. The reason behind is they are both having negative charge. So lone pair of electron repulsion is higher as compared to lone pair bond pair, is higher as compared to bond pair repulsion. So bond pair repulsion is very less. Okay, now next is guys VBT, valence bond theory. This is very important, the valence bond theory. So what will happen in valence bond theory? Attractive forces in valence bond theory VBT, attractive forces arise between nucleus of one atom and its own electron. Guys, we know, see, attractive force, when it will be attractive force, when we have a charge of opposite sign, positive negative charge, it will attract. Positive charge, same charges, it will repel. Negative charges, same charges, it will repel. So positive negative, different charges attract. So attractive force arises between nucleus of one atom and its own electron, because we know nucleus having the proton which is positive charge and electron is having negative charge. So positive charge, negative charge attracts. So N indicates the nucleus of atom A connected with electrons of atom A. So nucleus consists of proton which is having positive charge, electron which is having negative charge. The positive charge, negative charge, attractive force. Here also nucleus of atom B with electron of its same atom, see, and its own electron. Another condition is what? Attractive force arises between nucleus of one atom and electron of other atom, because we know nucleus and electron can attract, because nucleus consists of proton which is positive charge and electron is having negative charge. So positive charge, negative charge, it will attract. So in which condition they will attract? Either we will take the nucleus of one atom and electron of same atom, either we will take the nucleus of one atom and electron of other atom. We don't care which atom nucleus, which atom electron, we just care about the sign. So nucleus of atom A which consists of positive charge and electron of atom B which consists of negative charge. So positive charge, negative charge attract each other. Okay, we don't care which atom nucleus, which atom electron. No, we care only about the positive charge and negative charge. Okay. See electron, see here, repulsive force arises between electrons of two atoms. We will take the electrons of two atoms because both is negative charge, repel each other. Or repulsive force arises between nucleus of two atoms, because nucleus of two atoms means what? Nucleus of atom A, nucleus of atom B. Nucleus consists of positive charge will repel each other. So main thing is we will not see electron of which atom and nucleus of which atom. We will see that whether one is having positive charge, other is having negative charge, means attraction will happen. Both is having negative charge, repulsion, or both is having positive charge, repulsion. That's the thing we have to focus. Now this is a point you have to remember. Extent of overlapping increases, bond strength increases. VBT explain the formation and directional properties of bond. So what the VBT explained? The formation, how the formation will happen, positive charge, negative charge, and then direction. Okay, when two atoms came closer to each other, there is overlapping of one orbital. We know this, two atoms will come each other, overlapping of one orbital. Okay, so overlapping of atomic orbitals. So guys, see, overlapping of atomic orbitals is divided in three parts. First is positive overlapping. Positive overlapping means in phase overlap, like this. One will overlap upon other in phase overlapping. That is called positive overlap. See, when the phase of two interacting orbital is same, okay, so bond is formed. Another is negative overlapping. Negative overlapping means out phase overlap. Out phase overlap means when the phase of two interacting orbital is opposite, bond is not formed. In the examination they will ask like this: in phase overlap is which overlap? Positive overlap. Out phase overlap is which overlap? Negative overlap. Zero overlap means, guys, no overlapping is zero overlapping. Or they will ask in the examination like this: when the phase of two interacting orbital, is same, so what will happen to bond? Bond is formed. Or they will ask, when the phase of two interacting orbital is same, which overlapping? Positive overlapping. When the phase of two interacting orbital is opposite means what will happen, guys? Cancel each other, so bond is not formed. Negative overlapping. Zero overlapping means when the orientation of two interacting orbital is such that there is no overlapping. So no overlapping means what? Bond is not formed. Zero overlapping. So you have to remember these points also. Okay, next, types of overlapping and nature of covalent bond. Very simple. I see. Guys, we know covalent bond. We studied already covalent bond, van der Waals radius and all. Okay. Covalent bond may be classified into two types depending upon types of overlapping. It's a sigma bond and pi bond. So what is sigma bond? Sigma bond formed by end to end overlapping. Guys, you have to remember this. Sigma bond, when we will get the sigma bond? Sigma bond formed by end to end overlap. Okay. If we will do end to end overlap, it's a sigma bond, or we will say axial overlap, or we will say head on overlap. So combination of overlapping means SS overlapping, SP overlapping, PP overlapping will come under sigma bond. Next, pi bond. Pi bond means formed by sidewise overlapping or lateral overlapping. So pi bond, only PP overlapping will come in pi bond. So now strength of bond depends upon extent of overlapping, because here we have seen, guys, if there is increase in extent of overlapping, there is increase in bond strength. The bond strength is directly proportional on the extent of overlapping, how good the overlapping is. So if overlapping is good, bond strength is good. So sigma bond strength is very greater than pi bond, because in sigma bond we have a large extent of overlapping, in pi bond we have a small extent of overlapping. See, overlapping is nothing but like this overlap. Okay. Like this, 1 2 overlapping, here it's overlapping is happening. Okay, that is called overlap. Okay, now we'll see the single bond, double bond, triple bond, the number of sigma bond and pi bond. It is important, they ask in the examination. So if it is a single bond, sigma bond is 1, pi bond is 0. Guys, we know sigma bond indicates the single bond, pi bond indicates the double bond. If it is a double bond, then it consists of 1 sigma bond, means 1 single bond and 1 pi bond. If it is a triple bond, then 1 sigma bond and 2 pi bond. Very important, guys, you have to remember this. Now we'll come for hybridization. See, basic definition of hybridization, everyone knows the basic definition of hybridization. What are the basic definition of hybridization? Are bolo re pyare, joldi bolo. See, intermixing of atomic orbitals. So we know that atomic orbital intermixing. So atomic orbitals which are intermixing, they are having slightly different energies, they don't have the same energies. भैया देखो, बहुत इंपॉर्टेंट चीज अभी समझना है गाइस. What is happening? Atomic orbitals intermixing of which orbital? बोलो रे प्यारे. Yes, in hybridization, intermixing of atomic orbitals. So in hybridization, what will happen? Intermixing of which orbitals? Atomic orbitals, and that atomic orbitals is having slightly different energy. So what we will get final? Atomic orbitals will intermix, we will get the hybrid orbitals. So whatever the atomic orbital intermixing, they have slightly different energies. But whatever the final hybrid orbitals we are getting, they all are equal in energy. That is a very important point. Okay. So intermixing of atomic orbitals gives the hybrid orbitals. So intermixing of atomic orbitals. So which type of atomic orbitals? Of slightly different energy, so as to redistribute their energy, resulting in formation of new set of orbitals. So this orbital is what? New set of hybrid orbitals. So see, intermixing of atomic orbitals will give the new set of hybrid orbitals. So that's why its process is called as hybridization. So this is the intermixing of atomic orbitals having slightly different energy, and whatever we are getting the formation of new set of hybrid orbitals, they have equivalent energy and shape. So another important point is number of hybrid orbitals is equal to the number of atomic orbitals that get hybridized. If I am taking 3 atomic orbitals, means intermixing of 3 atomic orbitals which is having different energies, so we will get the same 3 hybrid orbitals which is having same energy. Okay, yes sir. So what is happening is atomic orbitals are intermixing, and what we are getting? Hybrid orbitals. So atomic orbitals are having different energies, but hybrid orbitals are having same energy. So number of hybrid orbitals whatever we are getting is equals to number of atomic orbitals that get hybridized. So the hybridized orbitals are always equal in energy and shape. So hybridized orbital means the final orbital what we are getting after intermixing of atomic orbital. So hybridized orbitals are always equal in energy and shape. Chalo re bhaiya. Hybrid orbitals are more effective in forming stable bond because they have equal energy than pure atomic orbitals, because atomic orbitals are pure. The reason behind is atomic orbitals does not have equal shape and energy re pyare. But hybrid orbitals have a effective stable bond because they have equal shape and equivalent energy. So hybrid orbitals are having minimum repulsion because they have equal energy and equal shape. Minimum repulsion between electron pair and have stable arrangement because stability depends upon repulsion. If it is having more repulsion, then no stable. Okay. It is not like how your life will go with that person. Repulsion is more, means fight, cheating, angriness, misunderstanding is more. So what is happening? Your bond is not stable. Anytime you will get the message like you deserve someone better than me, bond is breaking. Okay, so it is not necessary that only half filled orbitals participate in ion hybridization. In some case, even filled orbitals of valence shell takes place in hybridization. Important point, guys. So these are the types of hybridization. We have a different types of hybridization: SP, SP2, SP3, SP3D, DSP2, DSP3, SP3D2, D2SP3. These are the different types of hybridization. Okay, yes, sir. Okay. Okay. SP hybridization. Okay. So now we will see. We have a different types of hybridization. These are the different types of hybridization. We will see this. So guys, first we'll see about SP hybridization. So SP hybridization is also known as diagonal hybridization. So here guys, in SP, 1s and 1p orbitals are there. Okay. So each SP orbitals has 50% s character because we have 1 and 1 2. So 100 divided by 2 is 50. So each sp orbital has 50% s character and 50% p character. So geometry is linear geometry. The example is BeCl2. So bond angle is 180 degree. You have to remember these points. sp2 hybridization has 1s and 2p orbitals. So these are the orbitals. 1s means s, 2p means py and pz at y-axis and z-axis. So shape is trigonal planar. So each sp2 orbitals has 33% s character. The important thing is, guys, we have to understand the s character. What is the bond angle? 120 degree. And these are the examples. Now sp3 hybridization has 1s and 3p orbitals. So these are the orbitals s, px, py, pz. Shape is tetrahedral shape. Bond angle is 109.5 degree. So each sp3 orbitals have 25% s character. The s character is easy to find. Just count the total number. 1s and 3p. So 1 plus 3 is 4. So every time it is a percentage. Percentage means 100. 100 divided by 4. So whatever you are getting, 25. That is s character. 25% s character. Like this we will find the s character. Now guys, we know hybridization. Hybridization is formed by the steric number. This is very important, guys. How we will find the hybridization? Hybridization we will find by steric number. The steric number is what? Sigma bond plus lone pair. So first of all we will count how many sigma bond means single bond is there and how many lone pairs are there. Electron lone pair guys. So we will count that and then we will get the steric number. So whatever the value we will get, that's called steric number. So according to steric number, we will get the hybridization. According to hybridization, we will get the geometry. So if steric number is 2, hybridization is sp. Its shape is linear. Steric number is steric number. How we will count the, suppose we have any structure, in that we will see that suppose sigma bond is 2 and number of lone pair is 1, so 2 plus 1 is 3, the steric number is 3. The steric number is 3 means sp2 hybridization, trigonal planar. Steric number 4 means we have 2, either sp3 or dsp2. If sp3 means tetrahedral shape, dsp2 means square planar. Steric number 5 is again we have a 2, sp3d and dsp3. If it is sp3d, trigonal bipyramidal shape. If it is dsp3, square bipyramidal shape. Now steric number is 6. We have a two type of hybridization, sp3d2 and d2sp3. For both the shape is octahedral. Now next we will see is molecular orbital theory, MOT. So molecular orbital theory means, guys, the electrons in a molecule are present in various molecular orbitals. Guys, orbitals, you know, we had studied in orbital in quantum number. Okay. So what will happen? Electrons in the molecule are present in various molecular orbital. We know, right? As the electrons of atom are present in various atomic orbitals. So the electrons are present in atomic orbitals. So electrons are present in different molecular orbitals, because from atoms we will make the molecules. The atomic orbitals of comparable energy and proper symmetry combine to form molecular orbital. I just now have told you, guys. With atom we will find the molecules. So atomic orbitals combine to form molecular orbitals. So that's why here the electrons in molecules, if electrons in molecule are present in molecular orbitals. So electrons in molecule are present in molecular orbitals, and electrons of atoms are present in atomic orbitals. Okay, electrons in molecule, then molecular orbitals, electrons of atom, then atomic orbitals, and we know atomic orbitals combine to form molecular orbitals. Electrons in an atomic orbital is influenced by one nucleus. If electrons in atomic orbitals is influenced by one nucleus, but an electrons in molecular orbitals influenced by two or more nuclei. This is very important point. So molecular orbitals, how we will form the molecular orbitals? Molecular orbital formed is equal to number of combining atomic orbitals. How many number of atomic orbitals combine, that many number of molecular orbital will form. If two atomic orbitals will combine, we will get two molecular orbitals. So what are the two molecular orbitals? Bonding molecular orbitals and anti-bonding molecular orbitals. So bonding molecular orbital means already it is bonded. So when it is bonded means it is at higher stability. Higher stability means energy is less. Why energy is less, guys? Because it is stable. Stable means it is in arams. So less energy means it will not jump here there, it will be in stable mode. So that's why bonding molecular orbital is having lower energy and greater stability. But anti-bonding, it is anti-bonding, it's not bonded, then it is at less stability, because it is not bonded to less stability, and high energy means it will start sharing the electrons to bond with each other. So higher energy and lesser stability. The electron probability distribution. The electron probability distribution around a group of nuclei in a molecule is given by molecular orbital. Guys, anything in a molecule is given by molecular orbital. See, group of nuclei in molecule is given by molecular orbital, or anything of atom is given by atomic orbital. Like atomic orbitals, molecular orbitals are filled in accordance with Aufbau principle, Pauli exclusion principle, Hund's rule. We have studied about these three rules in the previous chapter, in the chapter number 3, and we know how by using the Aufbau principle, Pauli exclusion principle and Hund's rule we are going to fill the atomic orbitals. So same like molecular orbitals will also filled. Now guys, linear combination of atomic orbitals. Linear combination of atomic orbitals. So according to wave mechanism, atomic orbitals means it have wave function, and we will see the amplitude of electron wave. So according to wave mechanics, what is according to wave mechanics? Atomic orbitals is what it have wave function. So what is wave function? Amplitude of electron wave. Okay. What are the limitation of this? Limitation is difficult to explain for multi-electron systems, means for bigger system. Homonuclear diatomic hydrogen molecule. Homonuclear diatomic means where we have a two atoms. Diatomic hydrogen molecule. Diatomic hydrogen molecule means we have a two atoms of hydrogen molecule. Okay, homonuclear diatomic hydrogen. Di means two atoms. Diatomic means two atoms. Which two atom? Hydrogen. So hydrogen two atoms will become molecules. Homonuclear diatomic hydrogen molecule consisting of this wave function of A and B. This is wave function of A and B atoms. So each hydrogen atom in ground state has one electron in its 1s orbital. Guys, we know what are the electronic configuration of hydrogen atom? 1s1. So it have in ground state, it have one electron, and that also is present in 1s orbital. So we have a two wave function A and wave function B. So guys, we know that if wave function we are filling the electron like this, so in wave function B we will fill the electron like this. Correct? Okay. Now this is the important thing. Linear combination of atomic orbitals. If we will do the linear combination of atomic orbitals, we will get the molecular orbitals. So this is what, guys, this is the atomic orbitals. The combination of atomic orbitals, either plus or minus, we will get the MO, means molecular orbital. Okay. So guys, see here, this is the atomic orbitals. If we will take this wave function of A plus wave function of B, we will get the atomic orbital, that is sigma, means bonding molecular orbital. Okay, because see guys, what will happen here, if we will take the atomic orbitals, so we can take the atomic orbitals either plus or minus. So either plus or minus we will get the molecular orbital, because we know with atomic orbitals we will form the molecular orbitals. So guys, what will happen if I will take the atomic orbitals plus, so molecular orbital whatever we will get, it's a bonding molecular orbital. So same if I will take the atomic orbitals of wave function minus, then we will get a anti-bonding molecular orbital. Okay, so bonding molecular orbital is denoted by like this sigma, anti-bonding molecular orbital is denoted by sigma star. Okay, so guys, if atomic orbitals we will take plus, bonding molecular orbital. If atomic orbitals we are taking minus, anti-bonding molecular orbital. The bonding molecular orbital means it's a constructive interference. Anti-bonding means destructive interference. So destructive interference means electron density is 0 at nodal place. Now condition for combination of atomic orbitals. What are the condition for combination of atomic orbitals? How the atomic orbitals will combine? What are the conditions? So the combining atomic orbitals must have same or nearly the same energy, means almost same energy. Same energy means like this, 1s. It should not like 1s and 2s. No, 1s, it should be same energy. It's not 1 and 2, the energy will be different. The CAO means this combination of atomic orbital must have same symmetry about molecular axis. Then the CAO means combination of atomic orbital must overlap to maximum extent, because we know maximum strength means yes, bond strength will increase. Okay, next, energy level diagram for molecular orbital. Energy level diagram for molecular orbital. Guys, we have a two 1s atomic orbitals combined to form two molecular orbital. We know guys, how much atomic orbital will combine, that much molecular orbital will form. So if we will combine the two 1s atomic orbital, then we will get the two molecular orbital. So what are the molecular orbital? Yes guys, we know the molecular orbital, just we studied. If we will take the plus, we will get the bonding molecular orbital. If we will take the minus, we will get the anti-bonding molecular structure. Anti-bonding molecular orbital. The plus means bonding molecular orbital plus means we will get just sigma 1s. Minus means anti-bonding molecular orbital, where we will get star. Correct? This is only the concept. See, 2s and 2p atomic orbitals give rise to following 8 molecular orbital. Right? If you will take the 2s and 2p, very important, 2s and 2p atomic orbital, if you will take, it will give rise to 8 molecular orbitals. So for bonding molecular orbital, we'll get 1, 2, 3, 4, and anti-bonding molecular orbital will get 1, 2, 3, 4. Okay. Now understand one thing. How we will get 8? See, 2s, how much 2? And how much 2p? So 2 plus 2, 4. So 4 atomic orbitals will give 4 bonding molecular orbital and 4 anti-bonding molecular orbital. So 4 atomic means they are giving 4 only. 4 atomic orbitals means they are giving 4 molecular orbital only. But we know that molecular orbital is divided into 2. Bonding molecular orbital and anti-bonding molecular orbital. So 4 atomic orbital will give 4 molecular orbital. But that 4 is what? 4 bonding and 4 anti-bonding. So total is 8 molecular orbital. Okay. Electronic configuration and molecular behavior. So distribution of electrons in various molecule orbital is called electronic configuration. We know. So stability of molecule, guys, this is important. Stability of molecules. So guys, we know NB means N indicate the number of electrons occupying, B means bonding orbitals, and Na means number of electrons. Number of electrons in bonding orbital, and number of electrons in A means anti-bonding orbital. Okay. So guys, when molecule is stable, when number of electrons in bonding orbital is greater than number of electrons in anti-bonding orbital. When molecule is unstable, when number of electrons in bonding orbital is less than number of electrons in anti-bonding orbital. So we know, guys, this is the formula for bond order. Bond order is what? Half into, yes, number of electrons in bonding orbital minus number of electrons in anti-bonding orbital. So when we will get the positive bond order, when NB is greater than Na. So positive orbital means if this value, number of electrons in bonding orbital, is greater than number of electrons in anti-bonding orbital, then we have a positive bond order. Positive bond order means stable molecule. If, guys, number of electrons in bonding orbital is less than the number of electrons in anti-bonding orbital, then we will get the negative bond order, unstable molecules. In examination, they will give you the values of number of bonding and number of anti-bonding, and they will ask you whether it is stable molecule or unstable. So just we have to check it out. Okay. Magnetic nature, guys. Magnetic nature, we have to study about the two, diamagnetic and paramagnetic. Diamagnetic means no unpaired electrons. So no unpaired electron means it is repelled by magnetic field. Paramagnetic means presence of unpaired electrons, means attracted by magnetic field. Okay, bonding in some homonuclear diatomic molecules. See, in the examination they will not ask you to draw this diagram, but now wait a moment. Okay. See, bonding in some mononuclear diatomic. I know you know this type of bonding, you already studied in your PUC. Okay. So hydrogen bonding means H2. Hydrogen molecule means H2. H2 means between H and H. So they will share a single electrons. So each hydrogen atom has one electron. We know each hydrogen atom has one electron in 1s orbital. So electronic configuration of H2 means what? Sigma 1s2, because both is in bonding orbitals. So it will get bonded. Anti-bonding means which is not bonded, the electron which is not bonded, unpaired. So electronic configuration of H2 means these both are bonded. So it will be sigma 1s and how many electrons? 2 electrons. Okay. So bonding order means sigma 1s2, guys. You know I also know, you also know how to write the electronic configuration because you studied this in your PUC. Again, I'm not going to explain you how to write the electronic configuration because it's a time taking. If you don't know how to write the electronic configuration, please go and open your NCERT textbook or your notes what the teacher has given you in your college and just go through it. Okay, because this is a one shot crash course. Here I will not explain you this small part what you have already studied in your college in detail, because this video, if I will explain in detail, this 1.5 hour of video will become 3.5 hour or 4 hour. And it's not a crash course. The crash course will go like just a quick revision and only for the Kcet, which is like, you know, from past 10 years or 15 years, what the topics or what the question they are asking. So you can score almost like out of 60 marks you can score 50 plus in this Kcet chemistry. So electronic configuration is sigma 1s2, means bond order is what? Number of electrons in bonding orbital. So this is bonding electrons. See, this is bonding orbital. Sigma is bonding orbital. Sigma star is what? It's not a bonding orbital. It is anti-bonding orbital. So number of electron in bonding orbital means this is bonding orbital. So number of electron in bonding orbital is how many electrons? 2. So 2 minus number of electron in anti-bonding orbital. Anti-bonding orbital is not here only. So it's 0. Divided by 2 we'll get 1. 1 means what, guys? Single covalent bond. 1 means single covalent bond. You can see they have a single bond. Because this what we are finding. We are finding the bond order. The bond order is 1 means single bond. So single covalent bond. The single covalent bond means this like this. It's a diatomic. Diatomic means what? Diatomic means no unpaired electrons. So you can see here, guys, this we don't have a no unpaired electrons. No unpaired electrons. If no unpaired electron means this number of anti-bonding orbital is not there. So diamagnetic. Now carbon molecules C2. In exam mostly they will ask for H2 molecule and C2 molecule. C2 molecule. So electronic configuration of C2 molecule, we will write these are the electronic configuration of C2 molecule. Okay. So bond order is what? Number of electron present in bonding orbital. Bonding orbital means this 2. This is anti-bonding. This is bonding 4. This is anti-bonding. Okay. This both is bonding. Because see, pi is bonding. Star indicates the anti-bonding. Star indicates the anti-bonding. So bonding is 2. This is star. This is not a star. 4. This is star. This both is not a star. So 4 plus 2, 6 plus 2, 8. 8 minus anti-bonding means star. This one. So 2 here, star, 2, 4. So 8 minus 4, 4 by 4 is 2. So carbon molecule means what? This carbon have a double bond. So no unpaired electrons. So it's a diamagnetic. So bond order is what? Bond order is 2. 2 means carbon will have double bond. So carbon will have double bond. So diamagnetic, no unpaired electrons. Okay. Now next. Hydrogen bonding is what we know about hydrogen bonding. Attractive force which binds hydrogen atom of one molecule with electronegative atom of another molecule. So hydrogen bonding means, guys, the attractive force which bind, we will take the hydrogen atom. It should be hydrogen atom of one molecule with any electronegative atom of other molecule. Means we will take the two molecules in which one molecule should be hydrogen atom, other molecule means hydrogen atom, sorry, guys, that's only we will take two molecules. Okay, we will take the two molecules in which we will take a hydrogen atom of one molecule and then we will take any electronegative atom of other molecule. They both will connect through a hydrogen bonding. So this is a property of hydrogen bonding. So attractive force which bind hydrogen atom of one molecule with electronegative atom of other molecule. This is important. So hydrogen bonding, types of hydrogen bonding is we have two types of hydrogen bonding: intermolecular hydrogen bonding and intramolecular hydrogen bonding. So intermolecular hydrogen bonding means hydrogen bond is formed between different molecules. Okay, between different molecules, intermolecule. Intramolecular hydrogen bonding means hydrogen bond is formed within same molecules. This is important. Okay guys, this is done for the synopsis of chapter number 4. So in the next video we are going to start with the PYQs and hot questions of chapter number 4. So guys, see, don't go in the depth and in the detail. In the examination the question will ask from this much notes only. It will not ask in the depth and in the detail. Okay, so it will ask from these many questions only. Okay guys, if you're finding it interesting, please guys, I know you are watching, just like it, so it will give me a boost, like yes, you are watching, you are liking. And if any of your friend are there, please share it to them, so all will get benefit. So okay guys, thank you, bye bye, take care.